Hello. Hello, my name is Atul Gupta. Good morning, good afternoon, or good night, depending where you are. I am leading IoT efforts at Syntiant, and in this presentation, I would show how we can help to accelerate your edge compute. You can reach us at tinyml@syntiant.com, and this is our website where we showcase this TinyML board. So I wanted to put first in the context what we have to offer and how it fits in this edge versus compute kind of paradigm. Then we'll talk about what this Tiny platform is, what is the workflow, how you use it, where you would use it. In a workshop like this, ideally, you want to have the part, everybody has a part in their hand. But since we just announced this part, it would be a week or so before you can have this part in your hand. So in this presentation, I would explain what to expect from this part and how to use it when you get hold of this. Of course, you can always reach us or Edge Impulse if you have any issue. So we all know that artificial intelligence is a very compute intensive job. And we also know that in cloud, you can have pretty much all the compute you can do. So it's obvious that people would use cloud for artificial intelligence payloads. But there's a growing concern. People don't like that somebody is listening in to them all the time. And then there is a latency and reliability concerns. So Syntiant is actually providing a solution which takes care of these things. So first of all, what Syntiant is doing. So we are actually designing microchips which are purpose built. So we are designing ICs which are designed specifically for AI payloads. And then we designed it for like the inferences which are running on powered, like battery powered devices. So that means that it has to consume very low power. And that's we would actually show how these devices can enable a whole bunch of applications where things could be always on, they would be running on batteries, and yet they would do amazing artificial intelligence job. So you can see here is that this is our board, and this board is pretty small, so you can use as is in some of your pre-production quantities. Of course, you can always design your own board, and we would provide full support for that. But to just get started, if you want to use, you don't have to do any design of the hardware. And generally, it takes about 1,000 of volume before it will make sense to do your own board. For this board, there is no MOQ, and it is already cost optimized, so you can start using it. This board is, of course, it can be used in your system, but this is also a very good development vehicle. As a matter of fact, you can develop your applications and deploy it on the same platform. Since we know that in artificial intelligence, data is very important. In fact, AI kind of runs on data. So we actually made sure that the data capture is really easy, and you can capture a lot of data on this tiny board. So you can actually capture more than 3 days of continuous uncompressed audio data, or you can store 200 days of uncompressed sensor data, which means that you can set it up, put it somewhere you're collecting data, and it would be collecting the data. Maybe you would find that everything is great, but you want to do cost reduction or size reduction, then this board could also be used. So take this board, things you don't want, you can take them out, things you want to replace, and we are here to help you with this journey. So let's talk about what to expect from this board. This board actually is utilizing our NDP processor, which is the lowest power processor available. It actually only takes 140 microwatt power for audio applications and 100 microwatt power for sensor application. And some people ask, is that your standby current, or is it really during when you're fully utilizing its compute? So answer it is when you're fully utilizing its compute. That's what this power is. And yes, it is pretty much the same as other components you might think of, which are taking this much power in their sleep mode. So as I mentioned earlier, that the board is really small. It's 24 millimeter by 28 millimeter. And you can use the board as is in many of these applications. This is a complete system. So it has a PIMIC, it has a battery management, it has onboard micro SD slot. And in some cases, you can drive things directly. So you don't need even external relay or some kind of a driver. So people talk about privacy. And if we put any RF component on it, and right away people would say, well, what somebody else would be listening to this thing. So that's why we did not put any RF component on the board. And in some applications, that's all you need. You don't need any RF. You need to drive something which is local. But let's say that you do need to send a signal. In that case, different applications would be requiring to send signal for a short range, for long range, or across the globe. So this way, you can actually, like this board could work with the BLE, Wi-Fi, LoRa, GSM module, whichever you like. And there is a very simple expansion port. You can connect it, and there you go. So this way, the modularity would allow you to use any of RF connectivity of your choice. And if you really want privacy, then you're 100% sure that there's nothing, no information is leaking from the system. So let's look a little bit more on the size comparison. Generally, microcontroller development boards are a little bit bigger than a credit card. And that's like a typical size. The size is quite big, and you cannot really use that as is in your system. So what we are trying to show here is that the TinyML board is so small that it can't even fit in Apple Watch. Now, if your size is even important and you want it to be even smaller than this board, which is shown here, then here we are showing that NDP 101 chip, which is used here, is 5 by 5 millimeter. And this is about the size of this chip. Now, relatively, these sizes are actually shown here. For NDP 102, which is specific for sensing, is much smaller. And for voice and audio, the size is even smaller. So if your application requires even a smaller size, then we are here to help you, and we'll get you there. So let's quickly talk about the board, what's inside this board. So let's start with our NDP processor that does the compute during the sleep mode. It is connected to accelerometer and microphone directly, which means that the rest of the system could be in sleep, and the NDP would be making inferences based on these sensors or transducers. Now, when something is detected, then with the interrupt signal and a SPI interface, host processor would be woken up, and then it can take an action. So let's start from this side. Micro USB connection is provided, so we can program host processor. There is a NOR flash, which holds all the parameters for the neural network. Then you have micro SD card, which is intended for saving the data. You have RGB LED, so you would know what's going on in this board. This reset button can be used to put it in bootloader mode. In some cases, you want to put a switch a little bit further away or some other part of the chassis. So there is a port which is provided where you can have a breakout switch. And then I said earlier that this board is complete system. So there is a PIMIC. It is connected to LiPo battery, and then it can charge it, and it can be used it when there's no USB connection is there. As I said earlier that we do provide a 5-volt supply, which could be sufficient for certain actuators. And then there is a FET switch, so we can control that switch depending on your, let's say, action needed. You can turn on this switch. And then it goes into header, and this header also has some GPIOs which could be used for expansion port. And then there are 2 LDOs to supply IOs and the core voltages. So now maybe you want to know more about what this neural decision processor is all about, why it is so different, what makes it so unique. So one thing I want to say that this is not yet another ARM-based processor. Of course, there is an M0 here, but that is only used for housekeeping. The core of neural compute is done here, which is labeled as here Syntiant Core 1. So Syntiant is evolving the neural compute with the Syntiant Core 1, 2, etc. This particular neural network is implemented in a hard manner, which means that it's truly optimized, and that's where we get orders of magnitude throughput and efficiency. So most people would want to know, how does it compare to other solutions? It's very difficult to compare head to head because different solutions are running different type of neural networks, and the efficiency could be different. Still, we tried to do a fair comparison, and that is referenced here. And what our finding is that it has about 200 times less energy per inference. At the same time, we are also delivering 20 times more throughput. So this is what actually makes this board, make this technology so different from whatever else you can buy today. So now let's talk about democratization. You have heard this term several times yesterday. And here how we are leading this democratization. It's really, I would say, marvelous, I would say, because many people have heard about AI, but when you want to use it, then you find that you require a lot of hardcore knowledge about AI and machine learning. So with the help of Edge Impulse, now we have got a system where a user could be a subject matter expert. They may not know anything about AI or ML. They may not even know how to write a Python code or C code. They may not even heard of what a TensorFlow is. And yet they can do what they like to do. If they have imagination, if they have a product in their mind, they can actually take it from start to finish. And here we are there to help with the hardware, with the software. So we have written 2 tutorials. One is for Mac users and one is for Windows users. It takes about 2 hours to complete this tutorial. And in this tutorial, we would actually develop a neural network which would learn if somebody is saying go or stop. So I'll actually play a deployment video, but before that, I wanted to actually go through this these tutorials where you would see what to do when you have hardware in your hand. So let me open a document. So as I said, shown earlier, that if you click on the link, which is on the first page, that will take you on this page. And if you scroll down, you would see there are two tutorials. And if you scroll up, you would see there is a pre-order button. So I just see that there are some questions about if you can say something about pricing and availability. Yeah, so that's a good point. This part is readily available. This is, we are taking right now pre-orders. So if you click here, you would get to see the, you would be in the queue to get this part. We believe it would be available in 1 to 2 weeks. So it is just present, it would be delivered in 1 to 2 weeks. As far as price is concerned, I believe it is sub $50, but I think when you get to the website, you would be getting the exact price. So hopefully that answers your question. Okay. So if you can follow this particular tutorial, it has some information upfront. We talk about target audience, what you need to have before you get started. We talk about what is covered in this tutorial and what is not covered in this tutorial. And we are using this yellow arrow. You would see wherever you see it, that's where you have to click. We just try to make it as simple as possible. Over here, you would see email where you can click, and then if you have any question, then you can ask us. There's also an FAQ which is maintained by Edge Impulse, and that may also answer some of the questions you might be struggling with. The block diagram is here. And then some of the features of components used in this board are mentioned here. Then you may be interested to know what these pins are. So you can see there are 5 GPIOs, and then there is a 5-volt signal available here. These 2 pins are not connected to anything on the board. On the back side, you can see there is a slot for micro SD card. There is a switch here where you can put like a breakout switch. This tutorial has 3 sections. First section is about machine learning. And this is common for all operating systems. This would actually take you to Syntiant's, Edge Impulse website. That's where you can actually make your project. And then once you're ready, you would be deploying here. And then you can be doing real-time testing. So let me go a little bit deeper. Over here, it says that click here, and this is the starting point. So once you click here, it takes you on Edge Impulse website. And over here, it says clone this project. So let me go back. So we actually made a project with Edge Impulse, and most of the data is already kept here. This actually gives you a head start because, you know, Edge AI kind of runs on data. So we don't want you to be waiting and collecting data, only then you get started. So this project actually gets started with you with the already present data. And this data is coming from already published data on the internet. So once you start this project, then you have to follow along. You change the name of the project. Since you already have the data, but you probably want to see what's in the data. what does it look like? So you click here and you can sort it. So once you sort it, then there are 3 classifiers. So here there's a Go classifier. Maybe I'll zoom a little bit more. There is top classifier, but you also need an open set, because in machine learning, you have to tell what it is. So if somebody said something, and if you're only interested in go and stop, but at the same time, if there's something else, you also say that this is neither go nor stop. So that we classify that as an open set. Over here, we have called it Z underscore open set, because we wanted to keep this open set as the last one. Because in Edge Impulse Studio, these things are labeled, are presented as in alphabetical order. And then you can actually click on any of these sound samples and you can hear. So this is a go. So you click on it and then it would say go. Later on, once you want to upload these, you have to do the similar exercise. There is an easy couple of buttons and then you would be able to add or enrich this data. Or when you want to start your own new project with totally different things you want to do, then you collect all the data and upload it. Moving forward, over here you would see create impulse, and that's where you would set the duration of your tensor, and then how fast, like what is the size of your increments where you want to resample the data. So you follow that, and over here you would be adding a neural network. Okay. So we ask you to delete these ones first, and only then, because then it would give you, it will tell you that what things we are expecting out of you. So we deleted and then we add those back. Over here, you would see that we are adding Syntiant specific block, and that would be a queue. It would know that this is a Syntiant specific board. Then you add a neural network. Before moving on, you see that everything is good up to this point. As soon as we save a new impulse, you would see that these 2 steps, which otherwise were green, now they are gray, which means that we have to redo those ones. You can also see the spectrogram over here and other neural network input related things. Once you save parameters, it will take you to the next step. Sometimes you want to visualize the data, how separable these classifiers are. And if they're more separable, which means that it would be easier job for neural network and the quality would be good. So at this step, you can expect we have 3 classifiers, go, stop, and open set. Now, next step is to augment the data. So there are a couple of settings you can try. The setting which is recommended is here. Over here, you would see the neural network definition, and you have to say start training. It takes a 10-15 minutes, so be patient. And before moving on to the next step, make sure that the job is completed. Over here, it shows the accuracy. Overall accuracy we are getting is 98%, which is pretty good. So we talked about that. Okay, now it comes the fun part when we want to download this on our device. So click on deployment, and then you would see Syntiant TinyML board. We earlier have chosen few things which are related to Syntiant. That's how it knows which hardware you could choose. And then there's one more thing we have to optimize, which is posterior filter. So it does that for you. Once posterior filter are chosen and completed, you are ready to upload. But before you go and start uploading, few things you have to change on your computer too. So we are using Arduino CLI, and Arduino is a very easy to use software, which a lot of people know how to modify a firmware, and they can actually use the same thing here. So we are using Arduino CLI. There are few steps you have to follow so that it can be loaded in your computer. Okay. Once you have the Arduino CLI loaded in your computer, you have to set a path so that in some other window, you can give it a command and that runs seamlessly. So there are a couple of instructions. How would you set up the path? Once the path is set up, you can check if everything is good or not. So you go to in some other, like in a command prompt, you go to some other directory, and then you give this command arduino.cli, and it shows something like this, which means that everything is good, and then you can proceed to the next step. Okay. When you get the board, this is already programmed with word Alexa play music. So, and I'm going to actually show that how would you test when the board comes to you. And if it doesn't work for some reason, for example, there may be some issues with the accent, then we have provided a link. So if you click on this link, it would say Alexa play music, and the board should work with that because it's tested before shipping with that WAV file. When you connect the board, you should also need to monitor that it is recognized as a proper port. And there are a couple of steps which shows that what you're expecting. For example, it would show as a microphone, and it should show as a TinyML board, and it would come up as a new COM board. There may be some issues with the way your Windows is already set. So you might actually have to have some troubleshooting steps, which are easy, and they are mentioned here. Once these things are cleared, now let's go back where we left off earlier. So here, if you see on Edge Impulse website, there is a button that says build. So you click on it. This is probably the last step you have to do on Edge Impulse website. Once it's done successfully, it would automatically download a zip file in your download directory. So locate your download directory, and it should say something like this. This number may be different each time because it makes another version of it. The zip file, you can uncompress it. And then when you uncompress it, the file you need to click is flash_windows. And this is a batch mode file. It would actually get you started. First time when you run it, it also loads a few things and it gives you a couple of warnings. So you have to keep accepting those ones as the prompt says. Most of these things are actually happening first time. Next time when you do, you don't have to go through all the steps. It would be much faster. So over here, these are the, when you run this batch mode file, it would open up a command file. And when you see all these steps are written in that manner, which means that everything is going as per the plan. It pauses for 5 seconds in between once the firmware is written. So the way it works is that on the TinyML board, first the firmware is written, which goes into the host processor. And when host processor is working okay, then it transfers the neural network model. It takes few seconds. If there's any issue, then there are ways you can fix it, which is mentioned here. Otherwise, it's all done and you're ready to test. So let me go back to the presentation. So you have to probably allocate about 2 hours from finish to end. And in the end, you would be able to test it with the go and stop keywords. So let me play this video. Okay, now let me stop it here. Over here, if you see the board, I don't know how much you can see, but hopefully you can see a LED, which is over here, where I've stopped. It's a red LED. Okay. Let me back a little bit. So when you plug the board boots up and it goes through a sequence of this LED, RGB LED blinking. There are 2 LEDs which are on this corner. They are orange and green. You can ignore them for a minute and only focus on this RGB LED. It would blink blue 2 times, then red, and then green. And after that, it would be ready to accept a voice command. Alexa, play music. Alexa, stop music. So you just saw that it can actually show that it understood the command. First time it was blinking with the purple light, and the next time it was blinking with the red light. I think it may be more clear, so let me run it again. Alexa, play music. Alexa, stop. Okay, so this is how you would test when the board first comes. And after that, you would be clicking on this flash_windows batch file. And when you do that, you would see this red light would be blinking several times while it is transferring all the data. And the command window would be showing the steps which are happening. So let me play the video again. And now it is uploading the package. It takes a few seconds. And now it is checking if everything is uploaded properly. and I'm stopping it again. So once the new firmware and new package is loaded, you have to either click on the reset button or you can power on and off. So here I'm actually powering on and off this board. Now at this time you would notice that the sequence of this RGB LEDs is changed. And this is changed on purpose. So we would know that it was a factory default settings or is something user has changed. This time it would blink red and green. There would be no blue light blinking. So let me play the video again. Okay, so you saw that the two LEDs were blinking, first red and then green. And now it is ready to accept go and stop command. Okay. So of course, it won't accept Alexa play music, Alexa stop music anymore because we have changed the neural network. And then if you want to go back, we would actually show you how to do that. But now you are on your own. You can start having your own set of data, whatever you like, and have fun with this device. Let me go back to the presentation. Looks like there is a question. So let me just look at the question. Can you elaborate on how having two different cores, the ARM cortex-m and Syntiant, would make a difference from others for this system? So I'm assuming that you are asking question that in a system, there would be a host processor, and that might actually have an M0. And you also have NDP. So how do they work in together? So the way I would say that, yes, this board also has similar architecture. There is a host processor and that has M0, cortex M0. But during the normal mode, like during the inference mode, that is shut down, that is in the sleep mode. Because some of these host processors, they may be taking a lot of power and we wanted to save that power. So that M0 isn't really expected to do anything during the inferencing mode. While NDP 101 is on and it is doing the heavy lifting during the inferencing mode. And I'm assuming that you're not confusing with M0, which is also present in NDP 101. So yes, there is another M0 present in NDP 101. And its job is really to take the data from neural network, post-process it, and provide interrupts, etc., to the host processor. So I hope that answered your question. Otherwise, you can reach me or you can ask a follow-up question. So let's continue back. As I said earlier, that once you see these tutorials, we are not asking you to write any line of code. Yes, there are a few things you have to set up on your Windows machine or Mac machine so that some of the other softwares can run. But there's really not need for you to write any code. And we have tried, as I said earlier, this particular tutorial with the high school students, and they're able to finish in about 2 hours. And then people who don't even have any engineering background, like people coming from pharmaceutical field or other fields, and they're also able to complete the tutorial. So hopefully when you try it, it goes smoothly. If you have any issues, then we are here to help. you can reach us. There is a link in the tutorial itself, and you can also reach out to Edge Impulse. So I might be repeating myself, but if you want to know what are the steps on this workflow for any machine learning project in general. The very first step, of course, is data collection. And that is really the subject matter expertise. Like if you want to do something and you are expert in something, you may be better able to judge what's right, what's not. For example, you could be a doctor and you're looking some kind of X-ray, and then you would know this is good X-ray, this is not so good, like there is an issue there. That data is collected by the user and it has to be annotated. It would mean that this is something which is not to be alarmed, and this is something where you want to get alarmed. When it comes to voice, when it comes to motion sensing, sometimes it's very important that the way you collect the data is also taking consideration of the background or the context or the machine itself. How would you couple your machine to how would you couple your device to the machine which is vibrating, because the vibration may transfer differently. So you really want to take in situ data, and that's where this board comes handy, because you make your final product, you stick it in just like it is a final product, but this time with the micro SD card, and then you collect the data. So let's say you're collecting data with a good machine and a machine which is not working properly, and you collect hours and hours of data, and then it's already known which data is coming from where. So annotation is not such a big deal. You save it in 2 different directories and upload it. When data goes into Edge Impulse Studio, and that's where our collaboration really comes into fruition. There are a few steps which I just walked you through, but they're very, very easy steps. And you have to just click a couple of them, and then you keep going to the next level. And each level you would know that everything is done properly. And once you are done, you have generated a model, and all you need to do is download, which I just showed how it is, easy it is. And there you go. The board is up and you can start testing it. Again, I want to just emphasize that there are 2 modes of operation of this board. In inference mode, you would be using it as the customer would be using it. And the other mode is collecting data. So let's talk about this inference mode. So when you want to use an inference mode, you really want to do something. You really want to take an action. Something happens and you want to take an action. So what that action might be. Let's, for example, you want to turn on a faucet. So you say, okay, I want to say faucet on, and faucet starts giving water. In that case, you have to probably turn on an actuator or things like that. And if the power requirement is just within 5 volt and few amps of current, or maybe half amp of current, then you don't even need one more relay in between. These 2 ICs are used on the board, so you can refer to them and then figure it out if it is going to turn on your or drive your actuator or not. And if it doesn't, let's say you want to turn on a light switch and it's need to turn on like a 110 volt of switch, then you probably would be looking adding a relay or driver in between. So this would be a system which does not require any RF connectivity. Means that wherever you detect it, you can take an action locally. So that is the local action in mode. But in some other cases, let's say you are doing some remote sensing and the device is deployed, let's say in a farm, and you want to send data back, then you may be looking at LoRa connectivity. So then you would actually buy a module. And in some cases, you would find that this board fits directly onto some of the modules which are readily available. And this board can also power up those boards. So you don't even need 2 different supplies. And Since we are powering it on the other board would be in deep sleep and would not be wasting any power. Now you can also choose BLE interface, you can use Wi-Fi, as well as you can use NB IoT modules, GSM modules, whichever you like. So we did not put this BLE on the board, which sometimes people would do. But then at the same time, if they don't really use for BLE, then they are paying for this extra component. And then maybe taking some power, which is wasted power. So this is the reason why we actually separated out the RF connectivity and we didn't put it on the board. Not to mention that it guarantees privacy. So just on the board itself, it's 100% guaranteed. It's designed for privacy. Now let's get into the data collection mode. There's a micro SD card. You can actually save a lot of data on it. So is there privacy concern? I wouldn't worry about privacy here, because if somebody has installed a device, there is a physical thing. So if it has to leave your premise, physically it has to be taken out. So if you don't want it, then don't give it to them. Now the signal would not go without your knowledge. That's the privacy concern. So with the micro SD card, because it's a physical thing, the privacy concern is preserved here. And this is the same platform. So any artifact you might have where the microphone is there, and once you place it into some chassis, what is the path? All those things would be baked in this one. So the data you're collecting, you don't have to retrain it or do things differently, or sometimes the AI systems are pretty immune to these changes, but you never know. Maybe you're losing out a little bit of performance. Once in a while, you see false alarm, and that may be due to this small discrepancy. But here, if you're using the same equipment to collect the data, your results are going to be only better. And also this board is so small, and once you put the battery, it makes it a complete system, which means that you don't have to put any wire. You don't have to put micro USB cable while you're collecting data. You don't have to power it up with some power wires. And that actually allows you to take the data in the most natural manner. For example, if I want to put it on my ear and I want to actually take the data for a head gesture. Now imagine that I would be doing that, and with a lot of wires coming out, then my movement won't be the same. I would be biased. It would not be a natural movement. But if it is very small device and it looks like almost like the end device, then my head movement or my gestures would be exactly what you'd be expecting. And in some cases, you are interested to see those subtle differences. So how would be not using the same end equipment or end device? So that is really done here. One more point here is that this is a very small device. So if you have already designed the system and there is a small space, you can just jam this thing in. You don't have to connect it to anything else in your system. So you don't have to worry about finding power, this and that. And you would start collecting data right away. With the micro SD card, you have gigs of memory. It can easily save more than 3 days of uncompressed audio data or 200 days of sensor data. And that's a lot of data. Your probably battery would run out before the memory would run out. Then you may also ask, okay, why do I actually have to collect all the data all the time? When there is no activity, for example, then I don't want to collect the data. And there you go. Since the data collection also has our chip there, it can be continuously looking what's coming in, and you can actually relax thresholds. So it may actually capture more data than less data. But at the same time, for times when there is no activity happening, you would not be collecting any data. So this would reduce the clutter, and it would actually increase your capturing time window. And it would help you later with the annotation as well. So I'm just coming to conclude this presentation. I should not be really putting a mental block because with the microphone and motion sensor, the way you can use it is just too many ways you can use it. But to just name few, you can use microphone for a speech recognition. So that's an easy thing. Most people are already doing it. Keyword detection, command, short phrases, those things are easily done on this one. Now you can also actually do some interesting stuff for non-verbal or not even non-human speech. For example, if the machine is about to fail, and we know that machine starts failing, they would start making some sounds. And most often we debug those machines that something is going wrong. And of course, here, this can actually detect it. Dog barking, if you want to make a dog collar, then there you go. So you can actually use this kind of sounds which are very distinct, and this device would detect it without any issue. And on the motion sensor side, you can detect vibrations or any machine abnormalities, body gestures, or if somebody is trying to break into your house or car, then the kind of the ways they would be breaking and those vibrations could be detected by this device. And later on, you can train it. So just these are just very few examples, but I really want to emphasize that this forum is called Imagine, and I really like it because there is a reason why somebody chose, exactly chose this word imagine, because this is your imagination. And that is going to drive these applications. And we are really here to help you and make your dream come true. So let me conclude this presentation. We have shown this board's capabilities. We have shown that this is a very small board, so it could be a wearable device, it could fit in small spaces and all that. The amount of compute power it packs, this is pretty much like unprecedented. And not to mention the efficiency it has. This is a proven technology as well. We have already sold about 10 million devices using the same technology. So this is not a technology which is just coming off. This has been there for some time, and a lot of devices have been sold and used in the marketplace. Yes, this is a new technology, and yes, this could be difficult to use, but thanks to Edge Impulse, their platform actually takes care of all the details, and they are transparent to you. So if you just have to think about data, so you put the data in, and what you get out is a model, and that goes into our device. So this ease of programming is really a key feature here. And that allows you as a user to use your imagination and then deploy it. And that could be done in days, but not months. It could be done in days and weeks. This is using a microphone, and this is using a motion sensor. So you can actually have a device which is actually using either of them, or there could be applications where you want to use them in tandem, and it would work for that too. So with that, I would give it a pause and then see if there is any question. Okay, looks like there's no more question. So let me conclude this presentation. You can easily reach us. Let me just go back to the first slide. Yeah. TinyML@Syntiant.com. That's where you can reach us. You can visit our website, and you can order your parts and within a week or so, you would have it in your hand and give it a try. Thanks for joining. Thanks, bye.